let me just show you an example of how to work sometimes with base polysurface. Let me show the outcome that I want to show. I'll go to perspective. And you'll see that what I'm trying to do here is to basically have some kind of stones that I wanted to populate on top of a certain shape ring. In this case, I used just an oval kind of shape. And you'll see that this is also going in the kind of diagonal direction. And you'll see that I'm presented with this geometry and the geometry of my stones, and I want to populate those stones without distorting them. I want them their shape to be intact, basically. So how can I do something like that? Let's just look at the base geometry that we have here and how we can work with it. So I have my polysurface. If I try to use the surface and directly grid it, I'm assured to not be able to get these guiding lines or these guiding direction, but let's try it anyway. Try to grid using surface domain number. You'll see that this is actually, this shape is made up of three faces, so it's a polysurface. And each one of them is going to be divided in a certain way using the base surface of it. And if I come to model that, it's not going to give me any useful results, really. So a more appropriate approach to tackle this kind of a problem is to use some projection, is to use a guiding curves rather than the polysurface itself directly. So what I'll do is I know my direction of how I want to populate my stones. I project these curves to my polysurface, and I want to delete the input, and this will generate these curves. I'm just going to switch to the perspective view so you can see the kind of curves that has been projected to the polysurface. And since it has a thickness to it, it actually created two rows of curves, the top ones and the one going down the bottom. I don't care for the bottom ones, so I'm just going to unselect the top ones, which I want to keep, and delete the rest of them. So if I hide my shape, you're going to see only the lines that that I have generated using my base polysurface or geometry. Because paneling tools have the flexibility to work with any kind of geometry, including curves, then this is very appropriate in that particular situation. And also, if I look at my stone module here, you'll see that it's that's the shape of it, and I just gonna want to populate it on my surface or on my curves, so that that part of it is sticking out of the surface, and the rest of it is like buried inside of it. So if you look at the stone, that's the top part that I want it sticking out, and that's the bottom part that I want it to be inside, or kind of engraved inside embedded inside my polysurface. So what I generated a little plane to give me a guiding placement of my module. So the next step is I will have to generate my grid. So I have an option here to divide array of curves. Let me show it in the menu more clearly. Create a grid, and then there is divide array of curves. what it asks me is select a number of curves and use them as guiding for my, my grid. So divide array of curves, and it asks me if I want to sort the order of, I want to enforce certain direction or order. And I do in this case. So I select my first curve, my second curve, my third curve, press enter. And then it gives me an option of how do I want to divide the curves, by number, by distances, do I want to close the grid, all these options. And you should measure the distances, like how long or how big your curve is compared to your stone, and then decide how many number of spans are going to be useful in this case. If you look at the arrows here, it shows me that the red one is going in the predictable direction. So this is my row direction. But if I look at the green arrow, I see it going up. I would have expected it to go across, because that would be the V direction. So I immediately see there is something a bit fishy about this kind of grid. I'll commit it anyway, but before I populate my stone, let me just run really a quick panel 2D grid to see how the, like a box kind of grid will look like. Now look, it looks very, very messy. The screen will update in a second, and you'll see that this is not the kind of grid that I'm looking for sure, and that's not going to populate it properly. So let me see what happened with in this case. If I try to see if the seam or the start point of all these curves, they have to start from the same point, so they give me the right kind of look that I'm looking for. So let me just perpendicular. Let's say I want my V direction to be that direction, the direction of that little line that I just created. Now I have to move the start point or the seam of each one of these curves to match. And also I need to know that their direction, the direction of the curve, is going in the similar direction. So curve point in Rhino, or curve seam. So I select my closed curve, and you'll see how the seam is actually showing to be down the bottom there. I'm just going to just drag it to the new location that I'm happy with. I repeat the same with these. Now look at the seam here. And that the location of the seam was affected by the base geometry that I projected to. And this is why each one of these curves had a different kind of seam or a different starting point. And this is what messed up my grid. And now I moved all of them to this line. I'm just going to hide that line. I'm going to have a second attempt to create those array of curves and select them 1, 2, 3. And I can see in the preview straight away that the red and the green especially is going in the right direction. So I know that all the points are starting in the same kind of line. They are aligned properly. So I like that grid, but I'm still going to test it before populating the module. You'll notice me testing these curves with the panel grid 2D command quite a bit because this is quite useful way to be able to test your grid really quickly. Usually populating a module is not just time-consuming process, but also it's hard to figure out what went wrong, as opposed to using a box kind of pattern like this one. Just looking at the preview, I like it. I'm just going to exit the command with escape. I don't want to create these panels. I just wanted to test my grid. So what I'm doing here next is now I'm going to populate my module. And in this case, I'm going to use the Orient 2D or 3D module to grid. I'm using this because it's the only routine that doesn't deform, or I have the option not to deform my module. Much like the way flow along surface or array work, but it's quite customized to fit the grid. So I select my module object, and that would be the first step. And then it will ask me to pick a base point and the X direction and the Y direction here. And I have the option to select a fourth point. If I do, it's going to deform the module. If I don't, it's going to keep it intact, which I really want. And now it's showing me the directionality of my module. Now it's asking me for a grid, and also asking me if what kind of shift and base I want. Just because I ran that command before, my base and shift has been readjusted. So I'm just adjusting my options to start with the base 0, 0, shift by 1, extend across 1 module in the U direction, 1 module in the V direction. So I'm going to select my grid here, window select because it's not grouped. And now it's showing me a preview of the direction of my how it's going to be populated. So that's going to be the red arrow is going to be the U direction, the green is V direction, and the normal direction is the blue one. And I look at my module and I see it's matching it. So I press enter to accept, and I'll see all my stones being populated into in between these lines. Well, I guess what I want to communicate here is that you don't really have to use the Polysurface itself to generate the grids. To populate on top of it. You can use it to generate these curves that we use, projected it onto the Polysurface, and that's it. That was good enough for us to generate all these grids and then populate our stones on